Alright, here's another limiting reagent problem example. In this one, lithium metal reacts with nitrogen gas. According to the reaction, 6 lithium atoms, or 6 moles of lithium atoms, plus 1 N2 molecule, or 1 mole of N2, reacts to make 2 lithium nitride formulas, or 2 moles of lithium nitride. And these physical states are given in the little subscripts down here. Solid, gas, solid. It's balanced, and you can check that. So when 12.3 grams of lithium are put together with 10 grams of N2, how much lithium nitride could theoretically be made? That is, if there were no side reactions or losses when the chemical was purified. So this is the theoretical yield we could calculate. So why don't we stop the video here and try to do this problem yourself before you continue. Alright, here's the problem stated again in red, just as it was before. And I've written now some conversion factors that I got from the periodic table, namely using the atomic weight of lithium to write this conversion factor between grams and moles of lithium, using the atomic weight of nitrogen to figure out the molecular weight of nitrogen gas, N2, and using both the atomic weight of lithium and nitrogen to figure out the molecular weight of Li3N. So that's what I did here, grams and moles in this conversion factor. And then this last one came from the balanced reaction, that when you use 1 mole of N2, you use 6 moles of lithium. I could also write a conversion factor that says something like 6 moles of lithium makes 2 moles of lithium nitride. So there's connections between the products and the reactants, as well as reactants and reactants. So you can use whatever you need out of the balanced reaction using the coefficients to tell you the connections between the chemicals. Alright, since the problem does not state which reactant is in excess or which one limits, we need to figure it out. So I've just assumed that the lithium is all used up. I just picked one. There was no determining anything before. I just used the first one as my assumption that it would be completely consumed in the reaction. So I go through a little calculation to determine how much N2 I would need, and then compare that to the 10 grams that I'm given in the problem. So going from grams of lithium given to moles of lithium, and then using the balanced conversion factor from the balanced reaction, that 6 moles of lithium need 1 mole of N2. Changing back from moles of N2 to grams of N2, I determine I need 8.27 grams of N2, and we've got 10. So the nitrogen is in excess, and that the lithium would be completely consumed. Of course, if this had come out that there was not enough nitrogen, I would know that the nitrogen was the limiting reagent, and that I would base the next little calculation on nitrogen instead of lithium. But now I go ahead and calculate how many grams of lithium nitride I will make from 12.3 grams of lithium, because it's the limiting reagent. And you can see that this calculation looks just like the ones we've done before. 6 moles of lithium make 2 moles of lithium nitride, and of course I go back to grams. That's it.